Strings Revisited. Thus far we've had one complete nugget dealing with strings, and we've referenced them in just about every other nugget. However, we're now going to take our understanding of the string data type to the next level. First, I'm going to show you the advanced string methods, ways that you can do lots of interesting things with string data. Perhaps you need to trim off left hand, right side, or both side padded space data on certain strings. Well, you can do that. Suppose in your code you need to make sure that all user input gets formatted as uppercase only or lowercase. These are all simple examples of things we can do by employing Python's built-in string methods. Next, we'll look at another way to take string data and personalize it. This is string formatting, and it's one of several techniques that has undergone quite a bit of change from Python 2 to Python 3, so we'll want to make a note of that when we reach that point of the nugget. Third, we'll formally describe the input function. This is the chief way in Python that we can prompt the user to enter some data at the keyboard and then retrieve that input as a string to perform further processing on it. Without any further ado, let's get to work. String methods. You'll note at the top of this whiteboard I've given you a URL pointer to go into the Python version 3 online help, into their library subdirectory, and there's a page called Standard Types. Specifically, in this Standard Types article, there's a bookmark, section 5.6.1, called String Methods, that gives us a really nice list of all of the methods that we can apply to string objects. A lot of them are pretty self-explanatory. For instance, the capitalized method is going to return a copy of the string with only its first character capitalized. Count, we can change the encoding of a string. That may be useful, for instance, if we want to take strings and move them from the default Unicode and bring them back to ASCII for whatever reason. Find, format, some of these we've looked at already, but a lot of them are brand new. I just wanted to give you a heads up to this page so again you would know where to go to look up this information. You're probably more than sick and tired of my saying this, but remember, string data and numeric data are immutable. And I've come up with a diagram here down below that I've created using Microsoft Visio that I hope really drives home a couple of points. The immutability of strings, and also again that difference between the name and the object. So let's take a look at this diagram. We'll look at the first line first, reasonably enough. We're creating a name called A, and we're assigning the string value ABC to it. A is the variable, or the name. ABC is the data object that dynamic typing tells us, of course, is going to be a string. Now, we've said many times that string data is immutable. That is, we can't change this data object. If you tried to run A sub 1 and change just the one position in the index to something else, maybe D, you're going to get an error from the Python interpreter, you see. On the other hand, what can confuse you at first is it appears that you're overwriting the original data object if we then, for instance, assign A to a new data object. In this example, A plus ABC, which is going to wind up with ABC, and then actually this is a small typo. It should be ABC, ABC. The point that I want to make, friends, is to repeat that although we've taken A, the single name, we've pointed it to a new data object, ABC, ABC basically, the old object still exists in memory. Now that's important that Python keeps a track of this old data object because there may be references to this data object that still exist in your code, you see. And actually, that's how Python garbage collection works, by looking for data objects whose ref count, or number of references, has gone down to 0. We're going to demonstrate some advanced string methods by first of all creating a name, I'm calling it str1, that gives us this string literal called this is a sample string. And now what we'll do is begin to manipulate the string, manipulate the data object. Specifically, the first thing I'll do is do an str1 dot, and as we know by now, this brings up the methods that are attached to that member, to that name, which of course, to again extend our knowledge, dynamic typing is that these are methods that pertain to strings. And I'm going to make sure that I'm arrowed over capitalize. And here's a better tip. In the past, I've told you that you can strike the tab key to select one of these methods. What works better at least it's a little bit faster on my PC, is to use the space bar instead. So just to let you know. Now some of these advanced string methods don't have any arguments. You notice the online help tells us that capitalize simply runs and it outputs a string. And what it did here, capitalize, as I told you earlier, it takes the first letter in that string and it capitalizes it. Now let's do an str1.count and we'll pass in a substring, or a substring range really. We'll look for is. Once again, it helps if we refer to our name correctly. Change that to str1. And it tells us that there are 2 instances of is in the string. Now this is one of those things where we want to be not so reliant on what our code is. In other words, if we're completely convinced that we're calling this method properly, we want to still go back and check to make sure what's actually being done to our name. And that's yet another thing in favor of using the interactive interpreter in your development. Because when we look at the words, of course, is only occurs once, and perhaps in our program that's literally all we would want to bring back. But because this count is looking at just those 2 characters, you'll notice that THIS space IS. You see what I'm saying? So there's various ways that we can accomplish this. Perhaps the most logical one is to look for the string literal is with spaces in front of it and behind it. This just gives a reference of 1. So whereas count is a nice method for looking at the number of occurrences of a particular substring, we can also try find, which will give us the index position of the first occurrence of our substring. So if I look for the substring AMP, it tells us we're in position 11. Now let me echo back string 1. If we count from left to right, I'm here to tell you that amp and sample is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, sure enough, position 11 in that string. With both strings and numbers, you can use several varieties of is methods. For instance, we can do is upper to do testing, really. That's what the is command is used for. And is upper, very simply, comes back Boolean true, Boolean false on whether a particular string is in uppercase. Of course, that comes back false. If you need to force a particular case, like upper or lower, you can do that just by passing in, respectively, upper or lower. Now remember, str1 hasn't been changed, but what if we wanted to do strcap that took the data from that str1 name and capitalized it? Well, there you go. So now we have strcap that's capitalized and str1 that's all lowercase. Therefore, it stands to reason now in our testing we can try is upper on this guy, and it comes back Boolean true. Let's see what else we can do with string 1. How about title, which is going to put the string in title case where each word is started off with a capital letter. Let's now define a name called string 2. And this string happens to have intentionally some embedded space. Remember, spaces are nothing more than string characters, both in front of and behind it. So this can be useful for us because we can try out lstrip to strip out white space to the left of the first character in the string. You can also do rstrip that does the exact same thing on the right, or finally just the plain old strip function to remove all white space. That can be really helpful, especially when we're working with files and we're trying to clean data coming in from those files. Let's echo str1 again just so we remember what this was. And now let me show you another really particularly useful method called replace. And this is useful for substitution purposes, such as we could look for the first occurrence of sample and replace it with another string, test, you see? Yet again, remember, str1, the original data object still exists. If we want to actually do this substitution, we're going to need to define a new name, like so. Let's define str3. And the reason why I included 2 commas here is just to bring out a point, and that is there may be cases where you need to split a string into its constituent parts. I find it best to quote out the delimiter. You could have white space being a delimiter between characters or substrings in your string, or it could be a colon depending upon what you're doing. I'm using the comma as my delimiter, so I'm going to pass that in specifically to the split function, and notice what comes back. What you get as output is a list wherein each element in the list is split at the delimiter that you put in to the function. To do just the opposite, to do a join, I'll create a sample string for us. So we'll create this list and then watch what I'm going to do. I'm going to create a new name called week, run the join function on a quoted space, and then I'm going to pass in the sequence. You notice what that did, this is kind of a hack here. We're running join on, in this case, an empty space. So the resulting output is a single string that contains a space between each element in the original list. Have you ever worked with malmerge? Malmerge was one of the first things I learned how to do once I got into the Microsoft Office applications past the traditional beginner intermediate stage of depth. You'll recall in a malmerge, you're combining some database. That database in all likelihood contains names, addresses, etc. And you're selectively plugging in or substituting those data objects from your database into, say, mailing labels or a form letter. It could be a statement, a billing statement, and the like. That's exactly what I think of, the malmerge, when we consider string formatting in Python. It's a way to take your string data and personalize it based on static information or perhaps dynamic information that already exists in names. Now here's the deal. In Python 2, and supported still in Python 3, we can do string formatting expressions by using a syntax that comes directly from the C programming language, in particular its implementation of its printf function. Therefore, if you have experience using C, this should look very familiar. However, best practice now states that eventually it stands to reason that Python may drop support for this old C-style string formatting syntax that we're going to describe momentarily. And now what we have in Python 3 as a suggested approach to do string formatting is to do string formatting by means of a method call. Now let's take them one at a time. The C-style string formatting expressions work like this. Let's look at the first example of our sample code. I'm declaring a variable, or actually initializing a name, to be more Pythonic about it, and assigning the name s to a string literal, in which we have variable data plugged in, don't we? We have %s and then %d, such that we have blank has blank vacation days left, and then we're throwing in yet a third %sign, and then afterwards in parentheses we're providing what we're going to swap in. Now I want you to understand the s and d are pre-formatted string format codes. S stands for string, D stands for decimal. There's a whole bunch of these codes that you can look up in the Python documentation at your leisure. So these are not arbitrary. We couldn't just say %A has %B vacation days. We're going to get an error raised. So you have to define the data type in your string formatting variable expression, and then in order of appearance we can put our data. So in this case it's going to read Tim has 14 vacation days left. Isn't that cool? Now you can really modularize this code by maybe asking the user for input or reading data from a file, assigning that to names. Let's say you had your names mapped to a name called N and your vacation days mapped to V. We could just put in parentheses N comma V to make this code even more portable. You see, I'm just showing you the static approach here to get us started. So this is pretty straightforward. It works like a charm. You have to know the appropriate formatting code. The way it works now in terms of Python 3 and method calls, it's the same basic idea, but you'll notice that we use index values instead of these old school C formatting codes. So here we're again declaring a name called C, and in braces we have 0, 1. And again, position is important here. We want to start with 0. Indexing is always 0 based, and proceed through with our substitution sequentially going in that direction. The other thing that's important here is you'll notice the format call. When we call a function, or call a method in this case, you have the object, then we use dot, and then we can instantiate that function. So we're using the format method for strings, which takes n number of input parameters depending upon how many substitutions you have. Here we have just 2, 0 and 1. Now why is this better than the old school? Well, one thing that's cool is we don't have to worry about the format codes. And speaking of which, you notice that dynamic typing is taking place here. These index position values just deal with positions in your input list, your arguments, 0, 1, 2. Python will on the fly apply the appropriate data type to those data objects. The net result, though, is the same. Tim has 14 vacation days left. Good and good. Before we move on to our next demo, I want to just give a nod to this phrase here that I've called out with an exclamation mark, and that is Python 3000. Python 3000 and Py3k are two tongue-in-cheek nicknames that many in the Python community refer to for Python 3. I mentioned this at the beginning of our training, and it bears repeating again, that at least as of this recording in mid-April 2010, Python 2 is really the dominant version of Python used in the world today. Gradually, though, we're eventually going to move to the Python 3k platform as being the world standard. But I just wanted to yet again make that point. And if you do see references to Py3k or Python 3000, you'll now know what's meant by that. To lead off our demo of string formatting, I've created a name called SC, and you notice that I'm using the C-style old-school string formatting here, where %s represents a string data type that's pulled first in the subsequent list, and %d represents a decimal placeholder for the second object in the list, which we're saying is 10. So therefore we echo back the name SC, and it looks pretty good. Now just for grins, let me come back up and select the line, press enter, and let me just show you what happens if we are not aware of the fact that those placeholders actually are mapped to discrete letters of the alphabet that pertain to discrete data types. I'll use A and B. Of course, we get a traceback with that, no big surprise. Next, let's add a little Seinfeld fun to the mix. I've created a name called CSC that has the literal string no S for S. I brought this to you just to show you that it is possible to double up on these, that it's not a question of always having to have only one of each data type, but position is all important in that sequence. You'll notice I've supplied 2 words for substitution at the end of that string. No soup for you. Now, what if we wanted to modularize this code a little bit more? How about we define a name called R, that will be rest, W will be the weary. Now how we create these names, it could be through the input function, it could be through reading a file. I'm just statically assigning the names to a string data object for now. And now let me come up and redefine CSC. And this time, note that I'm not going to mess with the %s and %s. But what I am going to do to port this code, to modularize it a bit more, is that I'm now going to swap in those names. See? Same effect. No rest for the weary. Now we'll transition from the C style of doing string formatting to the Python 3 or Python 3000 format method variety. You'll see I've created a name called arb that has 3 substitutions in here, 0, 1, and 2, dot format, and then we're bringing in, as you can see plainly, 3 string literals. This, that, and the other. And then our final example, arb2, this one can too. This is to ask the question, well, what happens if we use 1-based sequencing instead of 0-based sequencing? Will Python know enough that we want to bring in bird for 1 and sing for 2? Nope, it sure doesn't. Remember that this is 0-based indexing. Let me correct that really quickly and we'll see what happens next. That's what I'm talking about. Obtaining keyboard input. In order to make our Python programs as flexible as possible, we need to have a method for bringing in, say, keyboard-based data, string data, from the user. And we use the input function to do this with. There was raw input in Python 2, so don't be surprised when you see references to raw input in Python articles that you read online. They're obviously referring to Python 2. In Python 3, we just have the input function that does the same thing. We've used this in a lot of demos thus far, you'll remember. We call the function and then supply an optional prompt, and the output of that function is, of course, a string. And you'll need to apply some kind of transformation function if you want to take that string value and turn it into, say, an integer or a float, you see? Now, above that, though, the whole keyboard input thing in Python, if you don't mind my technical language, comes to us from the standard library module called sys. Standard in or stdin essentially just refers to keyboard-based input, and in Python, standard out is the same standard output that you get, say, in Unix, Linux, and Mac OS, even Windows for that matter, and that is the screen. So in this module, we're concerned only with the standard in and standard out, However, it's possible for you to always redirect the output of a script file, in other words, change the standard out, by using the greater than operator. Yet again, we see an example of operator overloading here, where the greater than character is used in numeric comparisons, could even be used in string comparisons for that matter, and we also see it being used here for redirection. Therefore, at a shell prompt, we can call our script file using the Python executable, and we can use greater than and then supply a path and a destination file name, and all of the output of this program will be written to this text file instead of displayed on the traditional standard out, which is the computer screen. For this demonstration, in idle, we're going to do a File, New Window, and before doing anything else, we'll save the file. I'm going to just save it to the root of my C drive, and I'm going to call this kinput.py. Don't forget about that py. Let's step through the code here. The first thing I decided to have us do with this kinput.py file is to define two names, one for the lower bound and one for the upper bound. Obviously, your question is, okay, what's the purpose of this application? What you're doing here is being asked in this input statement for two numbers, and the program is going to generate a multiplication table for that range, you see. LB, you'll notice, is an input function which is going to come back as a string, so I've stacked that or embedded it inside of the int function to make sure that the lower bound number we get from the user is an integer and is therefore capable of doing math. UB, same thing. So we wind up at the end of this process with two integers ready to be used elsewhere. We're going to print a new line. You notice I'm embedding the new line in this print function in the string literal, and we're also going to use the format method to substitute what the user put in for his or her lower bound, line continuation character, you remember that, and then 1 is going to be the upper bound. We're calling the format function and just passing in LB and UB, so this will be dynamically suited to whatever the user puts in. Next, we're going to gather input on whether or not to proceed. We're defining a string name called verif, and we're asking for either a y or an n. The response name is going to be the result of this input from the user, and it's going to shift it to lowercase. That's going to trap the situation of what if a user were to put in uppercase y? What if a user were to put in uppercase n? By forcing their response to be lowercase, we're minimizing the risk of the application having an exception that's unhandled. Of course, if you're thinking Pythonically, you're thinking to yourself stuff like, well, what if the user puts in the word yes? What if the user puts in the word no? What if the user just presses enter or escape? Those are all examples of exceptions. In procedural programming, we want to anticipate everything possible that a user can do in the program and develop some routine, some exception handler to deal with those events. We're gradually getting there, though. We're looking at just in a narrow context right now and applying what we've learned thus far. Now, in the next couple of nuggets, we're going to start looking at conditional logic, so this if block is going to make a lot of sense. Right now, I'd just like you to skate along with me and take what I'm saying at face value. Our if logic says that if the response, this name here, is y, then we're going to run a simple for loop, which we'll also learn about in a very near future nugget, that iterates from the lower bound to the upper bound plus 1. Now the reason I put upper bound plus 1 here is because the for loop is not inclusive of the upper member of that range. So if the lower bound were 1 and the upper bound were 10, then this for loop will iterate from 1 until 10. We don't want that. We're actually going to go to whatever the user puts as his or her upper bound and print out the multiplication table for that range. The resulting output, as you see here, will be I, which in this case is the iterable where we're moving through, string literal x, just to denote multiplication, multiplier, that's the upper loop that we're running through, the number, the lower bound and upper bound that the user has put in, string literal equal, and then finally I times the multiplier. If the response is actually anything else, we could have done an elif to capture the n reply, but here I'm trying to bring in more exception handling to the code. So if the user does anything else besides press y, then we're going to print we're done and the program will terminate. Enough explanation. Let's open the Run menu and choose Run Module. We're asked for the lower bound. I'll put 1. Enter the upper bound. We'll put 3. Comes back. You chose 1 as your lower bound and 3 as your upper bound. Proceed. I'll say yes. And there we go. Now you notice how it's working here. The multiplication table is going from 1 until 10, and we've got lower bound plus 1, lower bound plus 2. Now there's more we could do to make this look prettier, but I hope you get the general idea. Let's come back to our code one more time to wrap up. The outside for loop takes the user's lower and upper bound and makes sure that we calculate a full 1 to 10 multiplying range for each value that the user plugs into this application. Strings Revisited Review. In this nugget, we delved further and deeper into how to use strings in Python 3. We began with looking at a hearty sampling of the string methods that Python makes available to us to format string output and pass things along in the way that we need those strings passed along in our Python application. We then looked at string formatting in both of its varieties, the Python 2/3 C style and then the late Python 2 but predominantly Python 3 format method function of doing string formatting and string substitution. Third, we looked at the input function formally. I hope now you have a really crystal clear idea of the syntax of the input command, how it's used, and how it can be really effective to modularize and make your code as accurate and goal-oriented as possible. I hope that this has been informative for you, and I'd like to thank you for viewing.